Hello, physical science students. Let's do activity 5, evaluating other energy resources. This is in the what are our choices for supplying energy for the future that we've been working on at learn.concord.org. So if you want to log into this activity, it's learn.concord.org and go to the menu, click on 5, and we're going to start here on page 1. There are energy sources to generate electricity. There are many ways to generate electricity. Natural gas is just one of the ways we've been exploring. In activities 3 and 4, we looked at drilling for natural gas and the impact that has on local communities, including water sources. Most ways of generating electricity rely on getting water to spin a turbine. The exceptions are wind, in which the turbine is spun directly, or solar photovoltaic, in which conversion to mechanical energy is not necessary. The panels just turn sunlight into electricity without any water or anything spinning. Some fuel sources are renewable. We can look down here. There's hydropower, solar, geothermal, wind, and biomass that are all renewable. Biomass, by the way, is burning things that you can grow. Renewable energy sources can be replaced. Biomass crops can be grown each year and are so vast as to be essentially unlimited as solar, hydro, wind, and geothermal are. Non-renewable sources may be quite abundant as some deposits of fossil fuels, but it takes many hundreds of thousands of years to replenish these used supplies, so they're not renewable. So some non-renewable sources are fossil fuels such as oils, coal, natural gas, or nuclear power. Some of the material to do nuclear power has to be mined, and there's a limited source of things like uranium. With all these different ways to generate electricity, which one is best? So it's your job here to decide what factors are important to consider in deciding the fuel source to be used for generating electricity. You can think about, is it renewable or not renewable? You can think about the air quality issues, like coal. If you burn coal, it has major impacts on air quality. Mining for coal, or even for materials to make solar panels, can cause damage to local ecosystems and disrupt local communities. Nuclear power, you have waste where you have to deal with it for maybe 1 million years before it stops being radioactive. Natural gas we've looked at has issues. Biomass, you have to use land to grow those crops every year. And you're dependent on the weather to grow those crops. Geothermal happens underground. It's pretty reliable, but earthquakes can disrupt those systems. Wind sometimes doesn't blow. Solar, sometimes the sun doesn't shine, especially here in Minnesota. Sometimes our winters are pretty grim. Hydropower, you can have droughts and the amount of water is going down. Hydropower, those dams also disrupt fish habitat. And so there are advantages and disadvantages to almost every power source. So I've given you a lot of things to think about. You should be able to formulate your answer to question 1. Here is a fabulous graph that tells us the net generation of electric power by sector. So if we look at this giant blue line on top, that blue line represents the net generation, or all the electricity generated from coal from 1950 to 2010 and a little bit beyond. It looks like coal went up and then it's gone down. The power source that's continually steadily risen is this green here, and that is natural gas. So which fuel source has provided most of the electricity from 1949 to 2015? So let's look at what 2015 here. What's the highest on this whole graph? It's probably the blue line, and you can figure out what that is. How did the generation of renewable energy change from 1949 to 2018? So let's look at the sources here. Solar is a little green line down here. It's not gone up too much. It's that faint green line. The red, hydropower, has been pretty steady. It looks like kind of a bunch of dams were built between the 60s and 70s, and that's been pretty steady. Petroleum has gone down. We can't really see too much going on with renewables, but it's definitely been going up. Wind, you can see wind start to come up right here. This black line is wind. So right between, say, 2005 and 2015, it really started to pick up. So the renewable energy in general didn't even really show up in this part of the graph, and it's just starting to show up as we start to kind of panic that we're going to run out of fossil fuels. So in this particular page, in order for a fuel source to be usable for generating electricity, it must be readily available. Because of geology and geography, various fuel sources are not evenly distributed across Earth. The slides below show the areas of relative abundance for electricity generating fuel sources used in the United States. So these are photovoltaic solar resources. And so question number 4 asks us, what areas of the country have the best solar resources? So it looks like the biggest numbers here are red and the smallest numbers are purple. So if we look for an area on the map right here, it looks like some of the southwestern states have the best areas for solar. Now we can still do solar in Minnesota. I have panels on top of my house right now that are making electricity right now. It doesn't mean that we can't do solar. It just means that there's more sunshine more of the year here. Actually, cold, sunny days are some of the best for solar panels because solar panels work more efficiently when they're cooler. Which areas of the country have the best wind resources? This is question 5. Let's see what else we can find here for maps. Oh, look, here's wind resources. Looks like Minnesota's right on the edge of this big purple ridge here, where you get the best wind resources. There's also a lot of good wind resources offshore, like in the ocean, that a lot of communities are starting to consider. A lot of the wind resources we have are in southern Minnesota, which makes sense based on this map. What areas of the country have the best geothermal resources? Well, let's go look at the next map. Oh, here's a great map of offshore wind resources, and you can see this kind of heat map here. A heat map is just anything that gives you different colors that represent different values. You can see the purple and red have really good offshore wind resources. So you can figure out what states those are. When we're looking at geothermal, which is using energy from the ground to heat water to turn a turbine, it looks like these western states are the best. Places where they have hot springs are usually the best for geothermal energy. However, there are geothermal systems that you can use on a small level for your own home. My friend has one and he heats his whole house. He had to drill a couple of very deep wells on his property and dig some tubing way down into the ground, but that's how he heats his house and he doesn't have to use natural gas. So, though that's the fourth map is your best bet for figuring out geothermal resources. And that's the West Coast. You can figure out what part of the West Coast. What areas of the country, for number 7, have the highest concentration of nuclear resources? Those are hydro. That's biomass. That's natural gas, that's shale. That's coal. Here are the uranium concentrations. You need uranium to do nuclear power. And again, the West has a lot of the uranium, but it looks like some of the eastern seaboard states have uranium as well. So you can formulate your own answer for question number 7 using map number 10. You can click on these little boxes here under the maps to find different ones. What area of the country have the most fossil fuel resources? So that's see slides 7, 8, and 9. You can look at those maps and figure out that on your own. What energy sources are the most abundant in your area of the country? Well, North Dakota has a lot of the Bakken Trail where they're getting natural gas and oil. We also have pretty good, we have some good wind resources here in terms of if we want to go renewable. We can go geothermal on a small scale. So our best renewable source is probably wind. Biomass, Minnesota does do some biomass generation. Biomass is growing something and then burning that something to get energy. Some people grow things on their fields, or they grow things and then they produce alcohol to use as a fuel. Gas production, this is probably before the Bakken Shale maybe. Here we go. Here's the Bakken Trail. Also extends into it's Canada and North Dakota. And that's not technically in Minnesota, but it's kind of next door. And we don't have much coal in Minnesota. It's mostly south of us. The Appalachian Mountains probably have the best sources of coal. But there's mountaintop mining there, and you can investigate that on your own. There's a lot of issues with mountaintop mining. They basically make the mountain disappear to get at the coal. And obviously people who live on the downside of the mountain are not too happy about having a mountain pushed into where they live. So air quality. It's a big issue, especially when we're talking about burning fossil fuels. Some electricity generating fuels result in air pollution and greenhouse gas emissions. Coal is probably the worst culprit. Burning garbage also has major issues. Air pollution includes particulate matter and invisible gases such as sulfur dioxide, which causes acid rain, nitrox, which causes acid rain, and that can form smog as well. That particular matter can cause lung cancer. And some particles are so tiny that as you breathe them in, they cross right into your bloodstream. Your lungs don't filter them out, and they can cause a lot of serious health issues. And even burning things like wood can cause some of that particulate matter. So I, with a wood fireplace, am guilty of making some of that particulate matter that contributes to air pollution. Greenhouse gases trap heat in the atmosphere, leading to global warming. Carbon dioxide and methane are 2 types of greenhouse gases. As you recall, natural gas is methane. The first slide shows the carbon dioxide emissions in millions of metric tons of electricity generating fuel sources. The second slide shows the methane emissions in millions of metric tons of electricity generating fuel sources. A third slide shows a table comparing the air pollution and greenhouse gas emissions of fuels to generate electricity in the United States. So here is carbon dioxide emitted by different fuels. Coal has been a big culprit until about 2008 or so, and a lot of those plants were kind of put to bed or retired, and natural gas plants, here this red line, started up. Natural gas is a little bit better for not making carbon dioxide, but again, it is also a limited fuel that comes with environmental consequences when you drill wells to find it. So this is methane's emissions in millions of metric tons of electricity generating fuel sources. So natural gas systems, since it is methane and some of that gas is going to escape into the atmosphere, natural gas systems create a lot of global warming. Coal mining has gone down a lot, so its contribution to global warming is decreasing. Petroleum is going down, and so is stationary combustion. Let's look at our third table here. So this looks at various different energy sources, if they produce air pollution, and how much greenhouse gas equivalents they put out. How much are they contributing to global warming? So this is sort of the global warming column, and this is the air pollution column. Which fuel source used to generate electricity emits the most carbon dioxide? Well, the table here will give you the best idea. That gives you the CO2 equivalent right here, so you can look at this chart and figure out which has the biggest number, which fuel source has the biggest number. Question 11, which fuel source used to generate electricity emits the most methane? Well, that's the second table here that shows methane sources. It looks like this blue line is the guilty culprit for emitting most methane. Earth's climate systems include greenhouse gases, incoming solar radiation, and outgoing infrared heat radiation. Describe how fossil fuel usage affects Earth's climate system. Well, if we go back up to this column, we can see a lot of these fossil fuels create a lot of CO2. The more CO2 we put in the atmosphere, the thicker the blanket that surrounds the Earth gets. And if the blanket is too thick, we get too warm. So the more carbon dioxide we put into the atmosphere, the more warming there is here on planet Earth. So most electricity sources, all but wind and solar, use water to generate electricity. For fuel-burning plants, the water is heated to steam to turn turbines that make electricity. In hydropower, the water is used directly to turn turbines. Water is also used in the extraction of fuels. For instance, water is used in hydraulic fracturing of shale to release oil and natural gas. That's going on in the Bakken Trail over in North Dakota. In the hydraulic fracturing of rock to release heat from geothermal reservoirs. So if you want to get geothermal energy out, you pump water and you fracture the rock where it's hot. But even if the extraction of a fuel doesn't require water, the energy source can still affect the quality of water. When materials are mined from the ground for potentially toxic compounds, they can leach into the water supply. Even though the generation of electricity from solar and wind resources doesn't use water, they can still affect the water supply. Solar panels and wind turbines both require rare earth minerals, which are mined from the ground. The manufacturing process can also release contaminants into water supplies. So, even though solar and wind are great for not producing pollution when they're in operation, to get those systems up and running, you have to do some mining and some manufacturing that may contribute to environmental degradation. So the table shows the water needs of several electricity generating sources. Which energy source used to generate electricity has the lowest environmental impact on water quality? Well, you've got these two up here. They don't have potentially toxic groundwater into discharge, and they don't need water to extract the fuel source. Sun just comes down and wind blows. So you can pick whichever one you want. You just need to be able to explain your answer. Remember, explain your answer in science uses claim, evidence, and reasoning. You want to make a claim, like I think wind or solar or natural gas is best. Then you want to state your evidence, why you think your claim is true, and then you want to use reasoning to connect your evidence to your claim. So land use and habitat destruction. All electricity generating sources take up space, but some take up more space than others. The amount of space that's needed to generate electricity, the more habitat destruction is possible. The slides below show the land use required for several different electricity generating sources. So let's see what we've got here. Solar installation, if it's ground mounted, takes up the native habitat of many desert organisms. The way to get around that, of course, is to put solar panels on top of buildings. Buildings with flat roofs, especially like Walmart, Kmart, big box stores, they have great roofs for solar. Wind power doesn't take up as much. You can see each base of each turbine takes up some farmland, but most of the land is still farmable, and farmers sometimes really like having wind turbines on their land because they get paid for hosting the wind turbines and they can still mostly use most of their land. Birds and bats may fly into the turbines. Noise can disrupt animal communications. And some people don't like living in the shadow of wind turbines because the shadow goes over their house and kind of freaks them out a little bit. So we tend to put them away from people. Hydropower blocks fish migration routes. Dams block the movement of migratory fish such as salmon. Dams impede the downstream movements of sediment to fertilizer and restore river deltas, and the upstream movement of nutrients to fertilize dense forest. So when you block fish from moving and you block sediment from moving down, you disrupt the natural ecosystem of a river. Open pit mining for coal or any other fuel, or even for the metals to make things like solar panels or wind turbines, that is going to disrupt a lot of ecosystems. We do have open pit mines here in Minnesota. They are now lakes. They used to be iron mines, and they have they left this sort of big hole in the earth, and they turned it turned into a lake over time. The forest regrew, and now one of the open pit mines is a mountain bike park and a recreation area. You can fish in the lake. All right, here's nuclear. All the nuclear waste sites, some fuel has a half-life thousands of years and needs to be stored securely to avoid releasing radioactivity into the environment. So there's all kinds of radioactive sites all over the United States. Those sites have to remain secure and protected and can't really be used for anything else for the next 10,000 to 50,000 years at least. So here's a table kind of summarizing, does having wind power on the land prevent other uses? Well, some uses. It's not so great habitat for birds, but you can still farm on it. Is habitat disrupted? Yep, birds and bats have a hard time, can run into wind turbines, and they're doing research here in Minnesota to try to prevent that. All energy sources have an ecological impact. Why is it important to consider land use when thinking about renewable energy sources? Well, we have just like we have limited amounts of fossil fuels, we have limited amounts of land. If you put renewable energy on it, you can't use it for something else, like building a school or farming or people's houses. Which energy source has the largest ecological impact on its surroundings? Well, you can make up your mind. Use the pictures up here to pick one. And make sure you explain your answer. Tell me which one you picked. Use some evidence from the graph, why you picked it, and then use reasoning to explain why the evidence supports your claim. Meeting 100% of the world's energy needs with ethanol from sugarcane would require nearly 3 times the amount of land now used for farming. But biofuels are still part of the energy supply. The most land-intensive of all renewable energy is biofuels. It's beneficial to have many sources for electricity generation, even though some sources are quite inefficient in some respects, such as biofuels. Biofuels can be good because you can grow a crop, like say corn, and then all the corn stalks can be burned for energy. So we can eat the corn and we can burn the rest of the plant. So a lot of biofuels are kind of leftovers. People burn sawdust from sawmills. They burn a lot of waste products that are kind of left over from other things. If we have a mix, it's great because some days the sun isn't shining, so we need a different energy source. Some days the wind isn't blowing, we need another energy source. Geothermal might be disrupted if there's an earthquake, so we need other energy sources. This is why we have a giant power grid all over the United States to kind of share energy around if things go wrong and energy systems are disrupted. So there are advantages and disadvantages to each electricity generating source. Some fuel sources such as wind and solar are readily available, but the efficiency of turning the energy into electricity until the mid-2010s was quite low. Some fuel sources are much rarer, like uranium, but very energy dense. Some fuels can be used up while others keep producing without being used up as electricity is generated. The cost of electricity generated from each fuel source takes into account the advantages and disadvantages of each source. The graph shows the U.S. Energy Information Administration's prediction for the cost of electricity in dollars per megawatt for several electricity generating sources in 2025. The height of each bar shows the range of prices. So if it's really unpredictable how expensive it's going to be to use natural gas, it's going to be a big bar. If it's going to be pretty predictable, it's going to be a tiny bar. Some sources such as biomass and offshore wind have large price ranges because we really haven't, for offshore wind, there's not a lot of those plants, so we don't know how long they last and how hard they are to maintain. Geothermal is pretty steady. That has a very tiny bar here. Biomass could depend on the weather. If we don't grow a lot of things like such as corn, or we quit growing corn and grow something else, and we don't have that waste material to burn, the price could change. So which energy source is used to generate electricity in the United States is the most cost effective? So here's the price. So lower prices, more efficient generation is going to be down on the scale. So down in here, you have your more efficient sources. So you can pick one of the sources that's down here and explain your answer. Once you're done answering all the questions, you want to hit show all. Once you've hit show all answers, you want to go to that report for tab, and you want to highlight all your answers, go down, And then you want to copy and paste all those answers into a document with your answers for activity 3, activity 4, this is activity 5, and then you'll also want to put activity 6 in that document. So put all 4 activities, 3, 4, 5, and 6, in that document, and then turn in that whole document as Lab 5.2. Thanks so much, everybody.